Hello everyone, welcome back to our Java programming series. In this session, we will learn handling requests and responses in servlets. This is session number 33, and in this lecture, we will understand how servlets receive data from users and send responses back to the browser. Before starting today's topics, let us quickly revise the previous lecture. We studied the servlet lifecycle and key servlet APIs, including methods like init method, service method, and destroy method. This knowledge is essential because request and response handling happens inside these lifecycle methods. Now let me ask you an important question. How does this Java servlet read the data entered by a user in a web form? For example, username, password or any input values. The answer lies in HTTP servlet request, which we will discuss in this session. By the end of this session, students will be able to understand how HTTP requests are handled, how responses are generated, and how servlets interact with web forms using request and response objects. Today's session is divided into five parts: introduction to servlets, HTTP request response model, handling HTTP requests, generating HTTP responses, implementation examples. A servlet is a Java program that runs on a server. It handles client requests and generates dynamic responses. In simple words, servlets extend the capabilities of a web server by adding Java-based processing logic. Servlets offer many advantages. They are portable and platform independent. They are robust due to Java strong typing. They provide high performance by efficiently using server resources, and they are scalable, meaning they can handle multiple requests at the same time. The servlet lifecycle consists of four main stages. First, the servlet class is loaded into memory. Second, the init method is called for initialization. Third, the servlet handles client request using service or do get or do post. Finally, the destroy method is called before the servlet is removed. This diagram shows the HTTP request response model. The client sends an HTTP request to the servlet. The servlet processes the request and sends an HTTP response back to the client. Let us understand this flow in detail. A client, usually a web browser, sends an HTTP request. The request reaches the servlet container. The servlet processes the request and generates a response. Finally, the server sends the response back to the client. HTTP stands for Hypertext Transfer Protocol. It is the foundation of communication on the web. Common HTTP methods are GET, which retrieves data from the server, and POST, which submits data to the server for processing. Servlets receive these requests and generate appropriate responses. Servlets handle requests using HTTP Servlet Request interface. This interface allows us to read form parameters, headers, and request body data. The servlet container automatically creates this object for every request. In this example, get parameter method is used to read form data. Get header method reads HTTP headers. Get request URI method gets the requested URL, and get method tells us whether the request is get or post. All client request information is encapsulated inside the HTTP Servlet Request object. After processing a request, the servlet generates a response using HTTP Servlet Response. This object helps us define content types, set status codes, manage headers, and write output to the browser. Important methods include set status method to set HTTP status codes, set content type method to specify response type, set header method to add response headers, and get writer method to send data to the client. An HTTP response consists of three main components: status codes like 200 OK, 404 not found, and 5 node internal server error. Content types such as text/HTML or application/JSON, and headers like content length and set cookie. This is an HTML login form. It collects username and password from the user and sends the data to a servlet using the post method. This form is the client side of a request response communication. In this task, the servlet validates user credentials. If the username and password are correct, it displays a welcome message. Otherwise, it shows an error message and redirects the user back to the login page. This servlet reads username and password using request.getParameter method. It compares them with hard-coded valid credentials. Based on the result, it generates either a success or failure response. The deployment descriptor maps the servlet name to a URL pattern. When the client accesses this URL, the corresponding servlet is executed. If valid credentials are entered, the servlet displays a welcome message along with the login success confirmation. As I earlier told you, this deployment descriptor web.xml file is not required if you are using the @web servlet annotation. Now let us look at the another activity. The task is to accept two numbers from the user, add them, and display the result using a servlet. This HTML form collects two numbers from the user and sends them to the servlet using the post method. The servlet reads the number using get parameter method, converts them into integers, performs addition, and displays the result as an HTML response. The deployment descriptor maps the add servlet to a URL pattern so that server knows which servlet to execute. The output displays the result of addition, confirming successful request handling and response generation. As usual, web.xml is not required if using @web servlet annotation. In the next lecture, we will work with form data initialization using init method, servlet config, and servlet context. These concepts help in sharing data across servlets and improving performance. Now we'll be solving a scenario-based or case-based programming problem. The problem is in front of us. An online shopping application uses servlets to manage product search and order processing. In the first part, as usual, we have to design a servlet to handle search requests and generate dynamic responses. B part, evaluate request response handling techniques used. C part, critically analyze error handling and user experience considerations. So, online shopping application will be creating a project. Online shopping example. As usual, in the search main Java, we have created a package called com.example and servlet file search servlet.java. In the search C folder, main web app, we are having one HTML file search.html. First of all, I'll be telling you search.html. So this HTML file provides a search interface for an online shopping application. It allows users to enter a product name and send the request to a servlet for processing. The first line is doc type HTML, declares the document type as HTML5, ensures proper rendering in modern browsers. Then HTML tag is there. It is a root element of the HTML document. All content of the web page is written inside this tag. Then we are having head tag and title tag. The head section contains metadata. Title defines the text shown on the browser tab as product search. Then body tag is there. It contains the all the visible content displayed on the web page. Then heading S2 displays a heading indicating the purpose of the page. S2 is used for section level heading. Then form tag, form action equal to search. Starts an HTML form for product search. Action equal to search sends the request to the servlet mapped with @webservlet/search. Method equal to get sends form data as query parameters in the URL. Get is suitable for search and data retrieval operations. Then product name, line number 10. Input type equal to text. It represents a text input field for entering the product name. Name is equal to product is used by the servlet to retrieve the entered value. Required ensures the field cannot be submitted empty. Then input type is equal to submit button that sends the form data to the server, triggers the search operation in the servlet. Slash form ends the form element, slash body and slash HTML properly closes the body and HTML document. This HTML page provides a product search form. The form submits user input to a servlet using the get method. The servlet processes the request and returns dynamic search results. Then I will be explaining this search servlet.java file, line number 1. So before explaining this code, let me tell the purpose of this search servlet file. Search servlet. This servlet handles product search request in an online shopping application. It retrieves a product name from the client, processes the request, and generates a dynamic HTML response. As usual, package statement is there, import statements are there. So first import statement, Jakarta.servlet.star is used for core servlet interfaces. Jakarta.servlet.http.star is used for HTTP specific servlet classes. Jakarta.servlet.annotation.webservlet is used for annotation-based servlet mapping. Java.io.star is used to provide print writer for sending output to the browser. Then line number 8 @webservlet annotation. This maps all requests with URL pattern slash search to the servlet. It eliminates the need for web.xml file. Any request sent to action equal to search is handled here. Then we are having public class search servlet line number 9. Let me close this project explorer. Line number 9, public class search servlet. So this extends HTTP servlet to handle HTTP request. It also enables overriding of do get and do post methods. Then serial version UID, this line, this is used for serialization and version control. This and prevents compatibility issues when the servlet is transferred or stored. Then we are having this do get method, line number 17. It handles HTTP GET request and it is suitable for search operations which retrieve data without modifying server state. Then response.set content type, line number 20, print writer. It specifies that the response is HTML content. Print writer is used to write dynamic output to the client browser. String product, line number 23. Uh, this highlighted piece of code begins the HTML response, displays a heading for the search results page. Then we are having this if statement. This if statement, line number 28, if statement checks if the user searched for the laptop, equals ignore case, allows case insensitive matching, and this highlighted piece of code dynamically displays matching products. Hard-coded values are used for demonstration only. Then this piece of code displays a message when no matching product is found. Then this line number 38, out.println, ahref equal to search.html, search again. So it allows the user to return to the search page, improves user navigation and experience. Then we close this body and HTML, properly closes the HTML document. This servlet handles product search functionality using the get method. It retrieves user input through HTTP servlet request, processes the search logic, and dynamically generates an HTML response using HTTP servlet response. So now we would like to run this code. So show view project explorer, online shopping example, clear. And now this search, we will run this HTML file search.html. Right click on this and run as server. Select this Tomcat version, click on finish. So product name you can search. For example, if you search for laptop and click on search, laptop price is there, gaming laptop price is there, and you can click on search again to search any other product. Thank you for watching this video. If you found it be helpful, please like, share, and subscribe to the channel. See you in the next session.